thought that that helicopter might have checked our social distancing.
Oh, the helicopter is checking whether...
Speaking of social distancing, that's what I'm going to do in this video. So I'm going to program another solution, which is social distancing. First, I'm gonna get these results. Not really great. They're pretty much, in fact, pretty much the same as if we didn't socially distance at all. Then I create. Then I try again, but with a different, a better way to do it, which I have in my mind. What we now do is we take every particle that's partially inside the zone. By the way, so I'm going to take every particle that's partially inside the zone and calculate how I should bounce off of them, each of them, and then we're going to average that to get the actual bouncing vector. I don't actually know how that went now, so because I didn't record that part of the video just yet, so I guess you could just see it from the video that's playing out right now. So now half of the population is not social distancing. So hopefully even though they do have to move this through this thick social distancing mass or something. The social distancing people were like pushed to get infected. Evil person.
So you have now implemented social distancing with 50% contagion, no quarantine, right?
No quarantine.
And better hygiene? Better hygiene is 50% contagion. I'm sorry. So those are all the conditions.
Yes.
And you told me that you're also planning to introduce some more realistic scenarios.
Yeah, in the next video I'm gonna do deaths. In the video after that, I'm going to model more realistic simulations than just meandering around in a box. That's just not what happens in the real world.
And maybe it makes sense to also simulate whatever is going to happen when you make the rules a little bit less strict.
Yeah, maybe it would also make sense to do it while to only turn on the rules after a certain number of people got infected. So that's.
Or as they're suggesting, when a certain number of intensive care units have been occupied. That has been the suggestion.
Or contact tracing. That's another idea. Contact tracing is when you actually track also who you've been in contact with, not just
like in an app.
So you quarantine those people as well. So
yeah, we've been watching a very interesting talk by Stephen Wolfram about how to implement that.
Yes.
What are your thoughts about that? Can we include that in a simulation? Like when people know, following their app and following their own movements, following their own data, that they have been in proximity of an infected person and voluntarily go in lockdown for themselves.
Yes, Stephen Wolfram suggested an app to do it. The drawback is that not everyone might have it. So I might include that in the simulation as well. So last time we built this quarantine simulation where the dots go into this quarantine. Today I'm going to not actually use that quarantine simulation. I'm just going to, so just in case you haven't watched the last video, they have a 20% chance of not having any symptoms, and if they do, they get, after a few frames, teleported into the quarantine. I'm not going to leave this running. I'm going to go back to the previous example, where we just had the dots meandering around. What I'm going to do in this video is I'm going to implement social distancing. So, most people, when they model a dot thing like this, they have some of the dots stay at home. But that's not a very good model for social distancing, as you might imagine. So we're going to do it a little bit differently today. What I'm going to do is I'm going to have them have a little zone around them where they want to avoid each other. So we're going to create, so let's, by the way, let's save this as CS04 social distancing. So So I'm gonna first just create a little zone around each one where they want to avoid each other. So I'm going to say I'm gonna have them each have also a variable zone. And I'm gonna say zone. Well, I want it to be larger, like 12. I'm gonna say zone. Zone times 2. Zone times 2. And I also want them to not have any field colors. I'm gonna say stroke. White fill. Yeah, so now you can see this little. Maybe they're a little bit too. I don't know. This zone is a little bit too tight, right? So I think we're just gonna have to make the zone a little bit larger. Okay, what is the radius of them? The radius is 6. So it's actually quite weird that they are. What is the radius of them? 6. And the radius of this one is 12. Oh yeah. It sort of makes sense. Okay, I think that I'm going to make it let's say I'm going to double it to 24. You can see a few of them are like overlapping the rectangle thingy. Anyway. But I'll hide the zone anyway. So for now, we're just gonna keep it. And I don't really know how not to keep it, so I'm just gonna keep it for now, and then when we refactor it, we're going to. So now we want to stop the particles from getting into the zone. I mean, they might not be able to get through the zone, not be able to not to get through the zone. In which case they'll just slip through and get infected anyway. But we're going to, you know, when it's like crowded, they can't just find their way through.
Hello.
Oh, hi, Nikki. So since you just joined, what we're doing is we're making a COVID-19 simulation where the green dots. Hang on, I'm gonna remove the green dots are susceptible. The red dots are infected, and the blue dots are recovered. So, and then every time a red dot touches a green, okay, it has a chance that it doesn't quite work, but you can see every time a sick person touches a healthy person, a susceptible person, the person that has a 50% chance of becoming sick as well.
So do you account for dead people too? Does that
I'm not accounting for dead people just yet. I think that's gonna be the simulation after this one. But right now we're going to work on the social distancing aspect.
Okay.
So so we have this zone around each person, which I'm drawing in white around each person. Now we're going to want to have each of them not be able to get through the zone. So we're going to. Okay, let's see here. How do we do this?
I'm going to be right back. 1 second.
Okay. Next. How do we make this them not be able to get through the zone? Now, I'm going to, let's say, shall I just want the people to get away from the closest one? And treat it as a collision?
Okay, I'm back.
So, okay, think I'll just have them be the closest. Just use the closest one. So we're gonna.
Have you defined a grid or something?
I haven't defined any grid, which is why it's gonna be slow, and I think it's only gonna get twice as slow, which is not really slow. If I get. So it's not like I have 1,000. I just have like 200 of them, which I think is going to be perfectly fine. So I'm gonna just.
But you also have to check the distance for the closest one. So.
Yeah, I also have to check the distance for the closest one. So, but it's not like it's going to get like 200 times as slow. So we're gonna. So I think it will still be tolerable. So the thing is, this check collision only knows about one other ball. So I think we're going to need to write another one. So I'm going to say check gonna say void check social collision. So, and it's gonna receive the whole list, the whole array of balls. Now I want to check. Okay. So I'm gonna say. Ball array of balls. Okay. I want to check the closest one. So I'm going to say ball. Wow. Ball closest equals. Equals okay, closest equals, let's see. We're gonna set it to null. I'm gonna say for every balls. Now I want to check the distance between them. So I'm going to say so easy JavaScript. Float d equals distance xy beta x beta y. Okay. Oh, it's position. Okay. What's position? Ah, this is gonna make it even clunkier. Wow. Okay. D equals. No, I'm going to say if D is less than, let's say, the zone plus the other ball's radius. Okay, then I'm going to set. Oh, by the way, I'm going to say. Oh, we also need a record distance. So I'm going to say float record D. Hi, David.
Hello, David. Hello, David.
So record D is this. Okay, I can't set it to like a large number. I can set it to a large number, but I can't say infinity. So I'm going to say.
Less than X.
How far apart can
Less
one
than
be?
Y.
So I'm going to say record D equals max int? No, max float. Max float. And I'm going to say record D equals, or maybe I have a fix. Yeah, I have a fix. Record D
A D
equals
minor.
0. I'm going to say record D 1 over D. And I'm going to say if D is greater than record D. If 1 over D is greater than record D. So 1 over D, let's think about this. 1 over D is, if it's really, really big, this could be really, really small, but not 0. So, yeah, but if, yeah. Yeah, okay, this works. And I'm going to say closest equals B. Okay? Again. Then we can just apply. Now, once we got the closest one, if closest if record D, which is the distance of the closest one, is less than, guess what? Zone plus v dot radius, then I can apply the exact same thing that I did before. Wait. So, zone plus closest dot radius. Okay. Potential null pointer access. But there are more than 0 both. Anyway. But there are more than 0 balls anyway, so I think we can just ignore this. Although it's good to error protect your code. But we're just prototyping. We're gonna say, I'm gonna write a separate function called collide. Which just does the collision. So we're going to just do all of this. Okay? I'm just going to abstract this away. And say ball. And it's just going to do all of this. And we need, we're going to fix all these errors, of course. I'm going to fix all these errors. Go like this. Okay, so now we have distance vect. I guess we could just pass those in. So I'm just going to say we need a vector. Anyway, we could do that. We could do that later. Okay, so I'm going to say p vector distance vect. Float vect mag and float mean distance. So now I just have everything. I've just abstracted that away to here, which means I don't need any of this. All of that collision stuff is now abstracted away into here, so I'm going to just call collide. With other distance vect think we're ready. Let me just check. Okay, everything is okay. Everything is okay, everybody. Let's try this. I hope this is not going to go crazy, but we're going to see here. Now, wait, where's the check social collision function? Oh, I'm in the wrong one. This is check social collision function. So now I'm going to say this is our closest variable. Now I need to compute the distance vector. So first I'm just going to say float min distance equals that. This is going to be min distance, right? Now I also want the distance vector, so I'm going to say float the vector equals p vector, and I want the displacement between this ball and the other ball. So I'm going to say e dot position. The variable b does not exist. Oh, it's closest. But it's not float, it's p vector. Okay, so float goes into so is okay. Oh, this is easy. I just call collide. Remember that whole function that I've written? I can just use it. Okay. So collide closest d vector record d and min distance. Okay, let's see this just in case it's wrong. I don't see any social collisions. So I think. Oh, I better do something with check social collisions. So I have, like, this function. I better do something with it. So I'm going to put it in here. So I'm just going to say check social collision false. Wait, whoops. Let's open everything up again. Hopefully this is going to work. I think it's working, actually. Yeah, I see some social collisions, but a few of them slip through. Yeah, you can see if they aren't that socially crowded. If they aren't that socially crowded, then okay. Well, it didn't really help.
how are we feeling on this absolute beast of a Wednesday?
Hi, DAS.
Yeah.
So I'm working on this coronavirus simulation.
Cool.
And so the green dots are. Let's just remove some of the stuff that I was working on just to have you get the idea of what I'm doing. So. So you can see every time, so the green dots are susceptible, the red dots are infected, and the blue dots are recovered. So you can see if the red one is so if a red one, so is infected one touches a green one, so it's a susceptible one. The susceptible one has a 50% chance that it will get infected as well.
That's very infectious.
So, okay, let's put ellipse in. So let's put I have this zone for the social distancing aspect. So I'm working on the social distancing aspect. So that if I turn on social distancing, it gets slower. But if you hang on. It's quite hard to spot, but you might see some collisions. Yeah, you see some collisions without them actually colliding with each other. Maybe I just broke my code, but you saw it. Okay. Hang on. It doesn't really flatten out the curve though, so we're going to increase the zone number. So we're going to increase it to say 36. It's going to get pretty crowded. I'm not going to actually draw that ellipse anymore. Just to.
Can you draw a curve based on the data you get from there?
It's in the top right.
Oh, I didn't see it. Cool.
So now they're socially distancing, which is hard to spot. But it is working. I don't see any of them socially distancing. If I put the ellipse back, let's go without the ellipse. I see some of them colliding without them touching each other. I think this is going to go right with a smaller population. So let's go back to that smaller social distancing zone. And let's put the ellipse back. But we're going to have the population, we're going to have the population, so we're going to make it 2 times smaller. It's definitely a bit faster. Ooh, okay, the graph is a little bit crazy here, so we're going to just have to fix it. It's definitely going faster, their code, but you don't see any social distancing. Maybe if I take it out. We're basically just tweaking now. Okay. Why don't I see any social distancing happening? Put the circle back? I definitely don't see any social distancing. Wow! That's a really flat curve.
I'm leaving for a bit. I'm going to reinstall Discord. Bye.
Jill.
Cheers. Anyway, I better just say bye to B because I can't say cheers since I just did. Anyway. So let's turn off the social distancing. So now they're not social distancing anymore. Now you can see it's going to quickly spread through the rest of the step. I take the social distancing back, put the social distancing back into account. Then they basically rarely infect each other. So, well, I got a lot of people now. So sometimes they do get. Okay, now 1/3 of the population is infected. I'm not sure if that social distancing has helped. Let's put the social distancing back to the larger zone. So if I put it, so now they're going to social distance more. You can see it's spreading more slowly. It is.
Yes.
The infection, the infected people still goes up to a maximum, but it still goes up to more than half the population, but definitely a little bit less than before. It's growing a bit more slowly. Let's put the social distancing back to. If I put the social distancing to really small, so this is a really small social distance. Why is the social distance thing? Anyway, let's tweak a little bit more. What happens if we go back to the larger population? 200 cases. 200 people, sorry. Whoa, the graph is crazy again, so we're gonna just fix that. Here. Here, back to that really small social distance. let's go back to that larger social distance. To the normal social distance, sorry. At this point, I think it's better to get rid of the...
Okay, I'm back.
So this is basically our first social distancing. Let's go to the large social distance. Let's go to an extreme social distance. Extreme one.
So is the radius around a ball the distance at which they start to avoid other balls?
Yes. It's the that's what I'm calling the social distance zone or the social distance. So we have a huge social distance factor now. Social distance zone, social distance, whatever you want to call it. Super high. Let's go back to the circle and display it. Whoa! It's getting really crowded. Let's only display the circle if it's infected. So I'm going to say, because otherwise it's just going to be crowded. Like, see, they're trying to stay away. All of them are trying to socially distance, even though I'm only displaying the circles for the infected one. That just as a little note. If I would show the circle for everyone, it would just be a miss. So so even though all of them are social distancing, just be aware of that. We haven't tried to use extreme social distance for the smaller population, so I'm going to try that. The graph. Anyway, let's graph. No, actually, no. Let's just get the larger population. Finally, I'm just going to leave some comments in for the other stuff that I did. Great, now. So I'm going to, I think I'm going to get the 24. So, 18. see here, it doesn't really flatten the curve at all. It's just not great. So what I'm gonna do instead is instead is this. Instead of taking just bouncing off of the closest person, we're going to calculate what would happen if the person bounced off of all of them, and then all of the people who are in the zone, and then average all of those. If there are no people in the zone, then we just keep going. It's doing nothing. So, I'm going to save this as CSO5. Better social distancing. So I need to make a pretty big change to the collision function. I need to return all of the data. So here's what I'm gonna do. This is gonna be a little bit crazy here, but we're going to say return a new p vector with these two. Okay. So I'm going to do this. And this. New vector, and I think now, okay, I'm gonna say p5 dot, no, not p vector dot add position to be final next year. Wait, what? This is going to return a p vector array. What? What is going on with Java here? Java is a really weird programming language. What the heck? Oh, hi, Nikki.
Hello, Simon.
Hi, Nikki. I'm glad that somebody joined. So,
What? Are you working on the Corona simulation still?
Yes, I am. And I have this issue that I just... And
You want to return an object?
no, this is Java. So, okay. So, this is Java, which is where curly braces are in the
yeah.
way. So,
Yeah.
So, we want to... And so I'm not sure why there is an error here. Anyway.
can't you just bracket them out with a square bracket?
That's not valid syntax in Java. In Java, the only way to make an array is using curly braces. Well, not the only way to make an array, but there is also the long way where you first initialize the length and then initialize the elements separately. But then
Yeah, this is array, I know.
But the quick and dirty way to make an array is this. So
Yeah.
I guess we're just gonna go for the long way. If you want. So I'm gonna say p vector array answer equals a new p vector array with 4 elements in it. I'm not finished writing the array yet, so that's why it's 4 elements. I'm gonna say answer index 0 equals this. Answer index 1 equals this. And we're going to return answer. Now, sorry, I'm refactoring a little bit here. Answer index 2 equals a new p vector. Answer index 2 dot x equals this. And answer index 2 dot y equals this particular thing. And then answer index 3 equals a new p vector. Okay? Next. Answer index 3 dot x. That there's an array is something. An array in Java is real. You have to really sort of work down with a hand code, so to speak. You have to
Oh my god.
assign the length of the array first to then be able to assign stuff to it, and then you can't actually add stuff to the array and remove stuff from the array. You can only set.
Do you hear the Windows error sound?
Yes, I do.
Why? Okay, I don't know why it gives me that.
But anyway, let's go. This thing. And answer index 3 dot y equals. Oh, it's just better to do it this way. Good job, myself. Anyway. Nice. Now we need to account for, in the very beginning, these two things here. So what we're going to have to do is, I'm afraid, we're going to say p vector new pos equals position dot copy. I'm going to call it new position because it's and p vector other new position other position copy. And now I'm going to work on new position. New position this is new other position. Right? Oh, it's other new position. Okay. Other new position. Yay.
Simon, couldn't you do like?
So just to give you some insight on what I'm doing here, this collide function used to actually update the positions of the velocities of the particles to sort of bounce them off of each other, but and now in order for me to do something different now, I need to have it return the new positions of velocities.
Yeah. Can you look in the voice chat thing? Isn't it better if you do it like this?
I could do it.
Then it works.
Hi, form of
instead of setting each index individually.
Yeah, I did. Yeah, that's exactly what I tried with the inline array. What I did is that's exactly what I tried first, and that didn't work.
In the return thing,
the only thing is I tried to put it on multiple lines to make it more readable. This is not really very readable because
it works.
It will get it works, but I would get a really long line of code, and it would and that would take me a while to sort of trace.
Also, if you do it in multiple lines, you can't, but you have to return it afterwards.
Oh.
This works too. So that works too, but you have to return it afterwards. You can't return the array you created in the return.
But I got this and it worked. So I want to.
Yeah.
So I want to. Okay. Now this is going to be. Okay. Do I use position anywhere? It's fine. Everywhere I use position. I'm gonna remove this anyway. Okay, this needs to be new position. New position. What do I do now? Cosine. Okay. Wait, I guess there's no. I guess that's all I need. Other the velocity. Wait, where's? Can I find position anywhere else? Let's go to here. So I wanted to make it case sensitive. Okay, final change. We're going to remove all of this. And now in check collision, I'm going to say p vector array C equals that. Now I'm going to say position set C index 0, other position set C index 1, velocity set C index 2, and other velocity set C index 3. I'm always always afraid to write collision code. But it's working for some reason or another. But now I've actually taken out the social distancing with this, but that doesn't matter because this will allow me to write some better social distancing code than I did before. So, let's say this was a particle I care about, and then this is the zone. That we care about. Now there might be other particles anywhere else. They might be touching the zone, they might be partially inside it, they might be completely outside. So there might be other particles. What we have done right now is just taking the closest one and just bounced off of it, even though it's not actually touching. So what we now do is we take every particle that's partially inside the zone. By the way, so I'm going to take every particle that's partially inside the zone and calculate how I should bounce off of them, each of them, and then we're going to average that to get the actual bouncing vector. So that is going to be what I'm going to do. Okay, I might hack the collision system, but which is to say, it might go mad, but maybe it will not go mad, and I'm going to see if it works. Okay. Next. How do we do this? So we're gonna find the average of all of them. So we don't need this record E anymore. We don't need this closest anymore. And now we're gonna let's say instead I'm gonna come up with an. So earlier on in this live stream or tutorial or whatever, I said that you can't add stuff to an array in Java. Processing does allow you to do that, but that actually makes a new array. There's a different. Well, luckily, there's a workaround for that, and it's an array list. So if I create an array list of balls, and I'm going to say that they're all too close. I don't know, might be a bad name. And it's going to be a new array list of balls. Next. I'm going to say if D is less than the zone plus B dot R, I'm going to say too close, add B. Oh, it's radius. Now I'm going to say I'm going to create another, and this is going to be just a plain old array. And this is going to be a p vector array. So this is going to be an array of arrays of vectors, if that makes sense. Oh, hi Zephyr, whoever that is.
Yeah, hi Zephyr.
Let's say collisions equals a new p-vector array, which is, okay, to equals dot size. So you have to use the size function for an array list instead of just the normal length. Now we're going to say for p-vector array C of collisions. Now we're going to need the average collision, so I'm going to say p-vector average C equals a new p-vector array with 4 elements in it. Oh, this collision thing doesn't just magically have all the. By the way, I don't need this. Because I can just say. I'm gonna say ball be in too close. I am gonna take all of the collision data. Hang on. I'm gonna take all the collision data. So p-vector array. Okay, first, what do I need? I need a distance vect. Distance vect equals p-vector what is it again? Subtract b dot position from position. Vector distance vect mag equals p-vector dot, wait, okay. Okay, wait. No, I'm gonna say distance vect dot mag and p-vector min distance.
I am back.
Okay, hi Nikki. So, I have added something to an array. You might think, how? Well, I didn't actually add something to an array. I added something to an array list, which is the equivalent of a flexibly sized array for Java.
But in processing, can't you just append things to an array?
Yeah, you can append, but that's a bit clunkier. And that actually makes a new array, so...
Oh, okay.
So that's clunkier. zone plus d dot radius. Now I'm gonna say, wait, what? Wait, what? This is a float. Ah, of course, this is a float and this is a float. Okay, right. So we have this average C, but we're first, we are first going to initialize average C, so I'm going to say for it's I equals 0, I less than 4, I plus plus. Average C index I equals a new P vector with, at 0, 0, but that's the default. So I'm going to say, here. Vector array C equals, I'm going to collide with ball B. Okay. Distance vect. Distance vect mag. Compute all of that here. Now I'm going to say I'm going to do this. I'm going to use the enhanced loop. So I'm going to say for P vector V of average C. I'm going to say v dot add C index. Oh no, we have to. Okay. Wait. Average C index I, add C index I. And finally, last thing, we are going to have to divide by the, wait, okay. We're going to have to for P vector V in average C. Average C in, okay, no, V dot divide, no, divide by size. So this is taking the average one. Now I'm going to say position equals average C index 0 and velocity equals average C index 2. Yay! Whoa! That's a really prominent social distancing effect. it basically just totally halts the epidemic in its tracks.
I think you should probably include the grid system now or something like that, because is it running slowly, or is it just the simulation speed?
I think he sets it on frame rate.
Wait! Okay, some of them seem to have escaped their little, box. In the words of 3 Blue Wonder, some of the little dots have escaped their little cage. Anyway. You can see. But I think this is a little bit too extreme. What happens if we lower that social distancing zone? Because this is just too extreme. It's just impossible.
Anyone ever heard of F-sharp?
F-sharp?
Yeah, F-sharp.
I do know that it exists. The only thing I basically know about F-sharp is that it exists. So, and it is a programming language. And why does it keep going slower and slower and slower? Some sort of like clock. Wait. This is just crazy. I think I may have slightly broken it. Look.
Is it still 50% contagion?
Yeah, but that doesn't matter because look. They just don't touch each other at all anymore.
But this is not realistic because we know that the viruses are floating around in air clouds. So even if you never come near anyone, you'll still be able to...
I do have a question though. Why do all the balls seem to go to the top left?
Yeah, that's a good question.
Maybe we should consider using real random data. Well, that is if you do use random data.
Where are they? What? If I make the population size larger, though, I'm afraid to because I think if I make the population, wait. So if I make the social I'm just curious, what happens if I make the social distancing zone larger? So, we've already tried 18, we've already tried 24, let's try 36. Whoa!
Yay!
They have like arranged themselves in a triangular lattice! Immediately.
That's like social distancing to the maximum.
If we make it even larger, though, so this is extreme social distance zone, they arrange themselves in a square lattice, which is...
I think you should enlarge your window.
So, they do escape, which is a thing I might fix. And I think I might also fix this issue that it seems to have even broken the infection. So they seem to have escaped. I think it would be better to check the social collision before checking the boundary collision. Because then, but they get stuck. They get. Okay, this is a little bit unrealistic. So a few, of course a few. Okay, it would be a little bit because a few people might forget to social distance or something like that, or maybe.
Yeah, they shouldn't all social distance. That's a great.
Yeah, because if they all social distance, then of course that virus is going to be eradicated very. Yeah. So I'm going to turn social distancing on only for, let's say, 70% of the population. So I'm going to say Boolean distancing and I'm going to say if random1 is less than 0.7, distancing is true. Otherwise, distancing is false. And I'm only going to turn on social distancing for 70% of the population this way. So I'm going to say if b.distancing Whoa! And now they're sort of doing crazy stuff. They're sort of like this. Wait, what? Okay. I'm going to have them have a yellow outline if they have a social distance. So I'm just. Stroke 255, 255, 0. So you can see the yellow ones social distance, and if they're not yellow, they don't socially distance. So this time our little red dot has turned out to social distancing. You see, they're like bringing it up. I think I'm going to say. They might go a little bit crazy, but who knows? Our little infected person happens to be social distancing. If we get lucky, we might not social distance. Yeah, now our infected person does not socially distance. might get lucky and infect somebody else who might not be social distancing. It's sort of like the social distancing things are air particles. And they have to move through, or maybe get, no, like water particles. And they have to move through this like thick air. Again, our infected person is not socially distancing, so. After a while, you might infect a person who's also not socially distancing. Oh, she recovered. Oh, now our infected person is social distancing again. Whoa! A few people just pushed him and like zip, and infected a few people. Because remember, the system is not perfect. Let's play with this parameter. Let's say you have not 70% but 90% chance of social distancing. So now only 10% of the population should not be social distancing. Okay? So, let's see if we can get lucky and get our infected person to not socially distance.
DJ's stream is starting.
I was just like moving through this. It's hard to find them, so just for people who haven't watched the rest of the stream, the yellow dots are social distancing, and the not yellow dots are social distancing. I'm making this circle around them and they are infected. If we get lucky, unlucky. Well, yeah, okay. So, oh, okay. We infected another person. Oops. So unpredictable. Okay. Anyway, now let's do it for 50%. So, not. I think I'm gonna leave it at 70% after I do this, but this is a low social distancing thing. So now half of the population is not social distancing. So hopefully. Even though they do have to move this through this thick social distancing mass or something. social distancing, people were like pushed to get infected. Evil person. Same happened for a few of them. Okay, this might be a failure, but anyway. Let's just let this run for a bit. Okay, some of the recovered people are social distancing. Everybody's social distancing, even though... Not everybody, but everybody who has a yellow outline is social distancing, even though only some of them have a circle, a white circle around them. Just so you can track them better. I don't know, I guess everybody who's infected is social distancing now, so I guess... Oh, there's one person who isn't social distancing and is infected. This is just some sort of unpredictable mess. Anyway. Are some of them even overlapping because of this? I don't think so. Is me playing with simulations fun? Kind of. Whoops. I guess we don't need the white circle though. I think that's gonna make the simulation go a lot faster. Yeah, they were social distancing people like get like crushed, and so they still might get infected, but they. See, this time, a non-social distancing person already got. Oh, hey, evil person flying around. There's almost always an evil person flying around. 70%. I think that's where I will leave this example. The simulation is definitely really buggy. Suffice to say, but it works. Got pushed. And now a few people kind of some people who are not social distancing. Not social distancing, people go off to infect more people. Whoa. Anyway, you can go download this example on your own. And you can go play with it. So thanks for watching this part 3, which I think is gonna end up miraculously short because this was easier than I expected. In part 4, I'm going to either implement deaths, because a lot of people were suggesting it. I think I'm gonna do that, and then the video following that might be a setup with many communities and travel between them, and maybe I'm gonna do some more realistic simulations, like only turning on the regulations after a certain moment in time. So that's just the plan for this particular series here. Other than that, goodbye. See you in the next video.